All right, here we go. Algebra 1A, day 1, term number 5. We're going to start off with the basics today. Algebra, like a lot of math, involves building a foundation and then continuing to add to it. So today we're going to start off with some vocabulary and then start dealing with integers. Anybody remember what integers are? Okay, that's part of it. That's a little too broad. So we got one suggestion that it's negative numbers. Another suggestion, I'm going to get rid of this virtual background. Another suggestion that it's numbers in general. Anybody at home got an idea?
A whole number. Excuse me.
What's that?
A whole number could be positive or negative or zero.
All right, excellent. Sometimes called, what I just wrote on the board was sometimes called the counting numbers. They are whole numbers. I'm not sure who that was that volunteered that, but that's the perfect answer. Whole numbers are ones you can put on a number line. 2, 3, 4, 5. -5, no decimals. They fit right on the number line at each one of the numbers. They are positive, negative, and zero. So, if any of you were here recently at one of our orientations where you heard me do a warm-up, I like talking about positives and negatives, combining positives and negatives more so than adding and subtracting. In my mind, it makes more sense. But not everybody likes to do it that way. So we'll talk about that in a bunch of different ways. So integers is where everything starts. All right, everybody's got one now. And what's on the screen is some basic vocabulary. The issue, a lot of times, I'm convinced, is a lot of times it's not so much a misunderstanding of the problem, but if we don't understand the vocabulary, how are we going to be able to answer some of these things if we don't even know what the words mean? There are more words in this word box at the top than there are problems on this page, I believe. Some of these are going to be essential words to know when we start solving equations. So anybody want to take a guess at the first one? A term in an expression.
Isn't that a zero pair?
Zero pair would have to be two numbers. Anybody at home know what that first blank would refer to?
The first it is constant.
Constant, yep. That's good. I don't know who that is at home that's doing that, but you're all over it today. Thank you.
Okay.
A constant. The determine an expression or equation that has a fixed value and does not contain variables. A constant is just a number. We know what 6 is. We know what 7 is. We know what a -4 is. Those don't change. That's why we can talk about constants. And constants we can find in all kinds of different situations. The next one, though, is really, really important when we start talking about solving equations or even in expressions. Because if I start using this term and you don't know what I'm referring to, it's going to be very hard to understand what I'm asking about. Wrapped up like this.
$1 million worth?
Say again?
So worth $1 million?
Seems like it is, yeah. I don't know what the deal is. Got boxes of this stuff. Anybody come up with the second one yet?
Yeah, can I answer?
Yeah.
Coefficient, a number that multiplies a variable.
Coefficient, yes.
Yeah, coefficient.
Coefficient.
Coefficient,
That's okay.
Yeah, thank you.
And what that really means is, in this term, if we have an equation 6x equals 18, and I say we need to divide by the coefficient of x, hopefully everybody will understand that that means 6. Hi. And who are you, ladies? Names? Stephanie?
Yes.
Okay. Just have a seat wherever you can. Emma Gonzalez?
Yes.
Okay. I don't know if I have enough copies made. We're looking at the vocabulary right now. I'm expecting to have this many people here. A lot of people will get coefficient and constant mixed up a lot. You guys have something to write on, something, a pen, a paper? Come to class, you need to bring something to write on or paper. If you don't have anything, I have pens, pencils in here. Lots of scratch paper. If I know you're going to be here every day, I can start making more copies. Was not sure what to expect for today at all. Glad you guys are here, that's for sure. So if I start saying multiply or divide by that coefficient, that's this number. Constant is the first one, coefficient. The third one should be a go away.
No.
The variable.
It's the variable. Yep, variable. And the giveaway here is this. A variable symbol usually a letter that represents an unknown quantity. Very variable is the, I think, the Spanish word for the same thing. It comes from the root word vary, which means changeable. The thing about these kind of equations, when we have a single variable, there's only one answer that's going to give you a true statement. There's only one possible number you can put in here that will make this true. Because this equation here is 6 times x. What number would replace that variable to equal 18? That's the problem that you're trying to solve. You divide both by 6. This is dividing by that coefficient. The variable in this case equals 3. But if I have a different problem, 6x equals 42, now x is going to be something different. It's an unknown when you start off. And when you get into more complicated questions, more complicated problems, 6x plus 3 equals 51, now you still maybe only have one answer, but it'll take a little bit different kind of work to figure it out. It just means it's an unknown before you start working on the problem. There you go. I got one extra copy of this. These handouts or these materials are all in Google Classroom. So even if you don't get everything written down today, you can always go back in Google Classroom. If you want me to print something out, stick around afterwards. You only got one period on Zoom today. If you need more help, stick around after that. And I can make other copies at that time. So how about number 4?
Algebraic expression.
Algebraic expression. Right. A mathematical phrase. If you think about math and algebra, especially like an English language sentence, a whole sentence has a beginning and a middle and an end. That's what an equation would be like. An expression does not have an equal sign. 6x plus 3 is an expression. I could add more variables. I can add some more terms. The problem is it's not solvable. There's no way to figure out what x equals. But it's an algebraic expression. It's algebraic because there's a variable. As soon as you add a variable, it becomes algebra. Because this is also an expression, but we know what that is. It's 9. I don't know what this is because I don't know what x stands for. It could be anything. So we have to be careful when we look at some of these problems. Is this an expression? Maybe we can simplify it, but we can't solve it. Or is it an actual equation? You guys able to hear me okay at home?
Yes.
Yes.
Okay. Yeah, this is a whole new territory for me today, so bear with me if just for today, hopefully this will get better. Okay, number 5 is what I was just talking about. I'm skipping that one because that's the numerical expression. It's a mathematical phrase involving numbers and operation symbols, but no variables. It's a phrase, it's a part of a sentence, like this one here, 6 plus 3. That's a numerical expression. This is algebraic. And you can see the word algebra right in it. Numerical has the root word from number in it. So number 7, we already talked about this one. Oh, no, I'm sorry, I'm getting ahead of myself. Six is the numerical expression. If I told you that number 7 was the word terms, would it make sense?
Yes.
That's what it is. Terms. Numbers or variables separated by addition or subtraction signs, pluses or minuses. So if we have a big 6x minus 3y plus 12 equals 29. 6x is a term. Minus 3y is a term. Sign goes with the term. Plus 12 is a term. 29 is a term. There's 4 terms in that particular problem. I just made it up just to demonstrate terms can be numbers or variables. They're just separated by pluses and minuses.
What was number 5?
Numerical expression. Number 5 is numerical expression.
I never see that number 6.
Oh, number 6. Yeah, you're right. I don't know who called me on that, but please do that again.
Number 5.
Every time I make a mistake, and I will make a lot of mistakes.
You said number 5, or you skipped number 5.
You are absolutely right, and I shouldn't have. Now that I see my mistake. The problem that I have, and you guys have been with me before, you know this is true. I get to thinking about the next thing, and I start saying something, and it doesn't always match up.
Number 6 is numerical.
6 is equation. 5 is the numerical expression. 6 is equation, and here's the giveaway. I didn't read it all the way through. It's got an equal sign. And all it means is this equals that. This is an equation. All of this equals 29. 6x minus 3y plus 12 equals 29. Well, it's not solvable, but it is an equation because it's got an equal sign. So anytime you see an equal sign, you know we're talking about an equation, and it is a mathematical sentence. That's the one that has a beginning, a middle, and an end. Right? If I have a simple equation, 6x plus 3 equals 24. Let's see, 24. That probably works. Here's the beginning, here's the middle, here's the end. My equal sign divides an equation, the left side and the right side. So it's a full sentence because it's got an equal sign. Okay, did I mess up on anything else? I'm serious, you guys need to call me on this stuff when I do. 7, terms. This is what we started with, number 8. Integers, yes. Whole number, which can be positive, negative, or 0. And most of what we're going to do today is talk about the rules for integers. And normally, for most people, that means adding, subtracting, multiplying, and dividing. I'm going to try to show you a couple different ways to think about those. Now, somebody earlier said 0 pair. That's actually number 9. A pair of numbers with a positive and negative sign whose sum is 0. It's actually the same number with the opposite sign. So if you have -9 and +9, combine those, you get 0. Because, again, if you saw my warm-up, I can write this like that also. 9 minus 9 means exactly the same thing. It equals 0. That is a 0 pair. Zero pairs come in extremely handy when we're solving equations. And whether you're talking about variables or integers, we can use them exactly the same way. And it may seem crazy at this point to say that negative x and positive x is a 0 pair, but it's true. They cancel each other out. Think about +1, -1. 0 pair. Put them together, you get 0. The thing about 0 pairs is they're the same distance apart from 0 on the number line. So if you pick -5 and +5, they come together at 0. That's why they're called 0 pairs. When we're solving equations, we have to use 0 pairs all the time. In a situation like this, I'm going to be saying we are canceling. This one cancels that one and vice versa. Questions, anybody?
No.
Okay, the next two go together. 10 and 11. The number that is repeatedly multiplied. It's the base. 11 is the exponent. This is exponents. Are a really common area for mistakes. But if you remember that exponent form is repeated multiplication, you should be fine. Here with this example, 7 to the 3rd power. 7 is my base. The exponent is 3. It's not 7 times 3. 7 times 7 times 7. You take this base number that many times. 7 times 7 times 7. So that's 49 times 7. 300 something. I don't know. I can't do that in my head. But the most common mistake that I'll see people do is say that that's 21. It's not 7 times 3. It's 7 multiplied against itself 3 times. All exponents work that way. And if you notice, I put a dot here. I'm not using x anymore for multiplication. Once we get into algebra, we don't use the x to multiply. It's variable. It's the most common variable, right? So when I had 6x equals 18, there's no dot or no anything in between the 6 and the x, but I know that that's multiplication because now we can show multiplication in a lot of different ways. No space, with a dot. You can put one of them in parentheses. You can put both numbers in parentheses. But we won't use X anymore to show multiplication. I still have some handouts that have X on it for multiplication. And I don't have the original, so I'm just kind of working with them. I tried to weed those out as much as possible. So multiplication now gets shown in a lot of different ways. Did you guys at home understand that when I was describing that?
Yeah.
Okay. All right, now the next, number 12.
Like terms.
Like terms, very good. Beat me to it. We'll probably spend half a day just talking about like terms. The thing about algebra, once you start combining stuff, like terms, they have to look alike. They have to, everything has to be the same about them. And so, if I have an expression with multiple terms in it, I'm going to look for the ones that I can put together. I'm trying to simplify things. So, 6x plus 3x plus 7, I can combine the 6x and the 3x. Right. Can't go any further though, because now these are not like terms. The 7 is just an integer. I don't know what 9 times x is. But this 6x is like 6 positive x's and 3 more x's. There's 9x right there. Those are like terms. But if I have 6x to the second power and 3x plus 7, now I don't have any like terms, because they have to have the same variables, the same exponents. What you're doing is combining the coefficients. Like in this one, I had 6 plus 3, because I have the same variable, and these x's are actually only to the first power. It'll never show as x to the first power. But once I get higher than a single, a 1 for an exponent, now I got to find others that have the same exponent though. Same exponent, same variable. You see this a lot in expressions and a lot in equation solving. Anybody want to take a crack at 13? Distributive. Who said that? Distributive property. Distributive property is one of the most useful things we will do in simplifying or solving problems. Distributive property. Right, so it's not showing up. Distributive property. What it means is we're distributing that term that's outside the parentheses. That's another way to show multiplication. It's this. In this example, here, A times the quantity B plus C, A times B, added to A times C. We're distributing that A by multiplication, because we got to multiply it against every term that's inside the parentheses. If there were 10 terms inside the parentheses, we would still do that with every single term. A times that, A times that, A times that, A times that. And the reason we have to do that is because in algebra, we don't know what things stand for sometimes. And I'm going to use an example here to show you why distributive property works. Six times x plus 2. I don't know what x is. I can simplify this by multiplying 6 times x and 6 times 2. That's all I can do, though. I don't know what x stands for, so I can't take it any further. When we have variables inside the parentheses, we have to do distributive property. Because when we have numbers, if I have 6 times the quantity 4 plus 3, you can do the distributive property, but you don't need to. Anybody remember PEMDAS? Please excuse my dear Aunt Sally.
Parentheses, exponents, multiply, divide, add, subtract.
Right, exactly. Parentheses, exponent, multiply, divide, add, subtract. That's the order that we do all this stuff in. In this case, when all I have is 4 plus 3 in the parentheses, I know what that is. That's 7. So 6 times 7 is 42. My favorite number it happens to be. But if I want to do the distributive property anyway, I'm still going to get the same answer. 6 times 4, 24. Plus 6 times 3, still 42. But the only time we really have to use it is when we have a variable or variables inside the parentheses. Very helpful when we do, though, because then we can start to simplify things and reduce the number of terms that we have. Okay, 14 and 15. Yeah, either one of these, I don't care which one you put in here. Because the way I look at it, every single problem that you do, you have to evaluate. Evaluate just means, what do I have? What am I working with? What do I do when I see this? What do I do when I see that? You have to do some evaluation with everything that you look at in algebra. Now, in this case, I said, okay, I can do distributive property and I can simplify this using the given operations to obtain a single numerical value. Well, I couldn't get a single numerical value, but I still simplified it. I went from 1, 2, 3 terms down to 2 terms when I had that distributive property. So whether you talk about evaluation or simplifying, it doesn't matter. You won't see that on a test anyhow. I won't be asking you the difference between simplifying and evaluating. And in fact, the reason that I'm giving you this vocabulary is not to test you from the standpoint that give me the definition of the distributive property. That doesn't do anybody any good. What we got to learn is how to use these things. Algebra is full of rules. So where do we? Yeah, Danielle, I'm having trouble with that right now. I'm not sure quite how to do that, okay? Let me show this last, and then I'll try one more thing, Danielle.
Thank you, teacher.
It's J.
J.
Please.
Okay.
Please. Yeah. The last one, an operation that undoes the effect of another. Inverse operation. That's how we solve equations. We use the inverse. Inverse just means opposite. So we can say inverse or opposite operation. Because in all of math, there's only 4 operations. Add, subtract, multiply, divide. Every problem in the universe is broken down into those 4 operations. There's variations within those, but adding and subtracting are opposites. Those are inverse. Multiplication and division are inverse. See if I can show you using my phone. I don't know if this will work or not. Probably going to be backwards. That was one of the things I noticed before. Because it looks backwards to me. I don't know if it is when you see that. I try to do it on the board and this all looks backwards. Does it look backwards to you guys at home?
No, it's fine.
Oh, hooray, okay. See, this is what I was talking about a minute ago with the expression. You don't need to do distributive property here because we could solve the parentheses in PEMDAS. We do that anyway first. But when we have the variable, we have to do the distributive property. 6 times x plus 6 times 2. That gives me 6x plus 12. Now, what I was just saying about opposites, inverse operations, 6 minus 3 equals 9. 9 minus 3 equals 6. 6 plus 3 equals 9. Sorry. Here's my opposites with adding and subtracting. What you do is turn the problem around. Same thing with multiplication and division. 6 times 3 is 18. 18 divided by 3 equals 6. And that's what we will end up doing all the time in equation solving. We're going to use opposites. You'll hear me 1,000 times this term ask you, what kind of problem is that? 6x equals 18. I'm going to say, what kind of problem is this? It's multiplication, right? So we have to know what the existing problem is in order to know what the opposite is. Because now, if I'm going to solve this, my opposite is going to be division. And that's what all equation solving is about. Using the opposites, we basically take PEMDAS and we work it backwards. I don't have any adding and subtracting. I got a multiplication problem, so I have to use the opposite, which is division. We'll get plenty of practice with all that. All right, questions about any of the vocabulary? Sure. All right. So one of the things that I've shared with everybody in Google Classroom something called a Jamboard. These are some things that I've created in the past, and then I just keep using them, reusing them. We're going to talk about rules for integers. This Jamboard here has the simplified version. And I'm going to talk about some examples here in just a minute. But I know at least one person has gone on to this. I shared it so everybody can edit it if they want to. This is a Jamboard is a Google product. So if you're signed in with your Excel Center email address, I know it says excelcenter.org, but that is still a Google product. It's a Google email address, which is the corporate version. If you go, I'm in Jamboard right now. Anytime you are logged in Google Chrome, you see up here in the right-hand corner, I put a picture in there so I know that that's my account. You can do that also. When I just move the mouse over it, it shows what account I'm logged into. All the stuff that we're doing in Google Classroom, all the materials, you have to be in your excelcenter.org email address. Okay, now anything else, like here's my calendar for this week. Anytime I'm in another Google product and I see these 9 dots up here in the upper right-hand corner, that's going to take you to any other Google product you need. YouTube, Gmail, Calendar. You guys all have all these apps also already loaded. Comes with Google. You can go down here to find Jamboard. That'll allow you to open up any of these Jamboard files. Scroll even further down, you get into Classroom. You have a question? You gotta go? Yeah. Okay. Yeah, don't worry about it. Stay in touch. So if you're not sure how to bounce around or go between, one of these apps and another, it's all up here with these 9 dots, and then make sure that you're logged in with the correct account. Now, if you have more than one Google account, like I have like 5, you can add as many accounts as you want to in here. See, I have my primary personal one in here too, because that's what I use to log in as a separate person, sometimes on a Zoom account. So I keep it handy. But you can add any other Google accounts that you want by just clicking on your identity up there in that corner. So these 9 dots and this thing up here where your face is, or sometimes it might just have your first initial, really critical for getting around in Google. Yeah, somebody's already working on it. Yeah, see it. Good. I see you up there now. Good. It's editable, so any changes you make on that, everybody else is going to see. That's okay. Questions so far? Anybody?
Jay,
Yes.
did you get my work?
Is this Esma?
Yes, Asma.
Yes. Yeah, I saw it. It's
Sorry
good.
Sorry about the first, because this is the first time I use the app.
Yeah, and this is not for grading. This is for practice.
Oh, okay.
And the only things that I will be grading are the ones that say assignment.
Oh, okay.
Okay. Everything else is just for reference.
Okay, thank you.
If we go into Google Classroom, all this stuff here under integer operations says course materials. If you look in your stream, Jay Alley posted new material. Those are all just reference materials. You can use them to practice with. It's there for you to study with if you need to. Some of them are like note sheets that if you're not sure what's important, what to write down, that's what they're there for. Down here, posted a new assignment. That's going to go into the grading. Anything that says assignment will be graded. Everything that says materials is just for practice. Okay, so let me go back to the materials I want to look at next. Okay, so here's the first slideshow that goes through some of the rules involving adding. We're talking about adding. We're going to know what 0 pair means. We've already talked about integers. We can compare and put them in order. For instance, if you had a string of numbers and you had to put them in order from lowest to highest, you're going to want any negative numbers on the left, and then you're going to get more and more positive as you go to the right. Then lastly, we can add integers. Here's an example of the integers like we just talked about. Positive, negative, and 0. Any that will fit nice and neat on a number line. Now, temperature is one of my favorite things to use as an example. You know, we use integers in everything. Money, age, temperature, you name it. Day of the week. Now, the thing about integers is we got to think about how these are actually used. If in this example, somebody borrows $1 and then a week later they pay it back, what's the total? 0. That's a perfect example of a 0 pair. It's -1 when we borrow the money, +1 when we pay it back. So that can, putting this stuff in terms of dollars sometimes can really be helpful with integer operations, adding and subtracting. And that's what 0 pairs do. Here's some examples: -9 and +9, 15 and -15. So again, with money, is it worse if Miss Sylvia owes Aaron $1 or Jayla $3? $3. That's -3. If you write a check and there's not enough money in your bank account, you're going to be minus on your bank account. You're going to be in the hole. It's going to be negative. Now, what about this next one? Is it colder if it's -10 or -8 Fahrenheit? -10, right. It's farther away from 0. And the thing that I usually show for negative numbers, and this is where it comes in, the traditional number line is horizontal. This is another good way to think about positives and negatives sometimes too. If you have a vertical number line that looks like a thermometer, well, now when you go down, let's say we're starting at 5 and it's getting colder. When we go down, now we're going below 0. So when we go down, it's minus. On a horizontal number line, when we go left, it's minus. When we go right, it's positive. The thermometer example just gives you another way to think about negative numbers. And the example I really like to talk about is if it's -1 degree tonight and it gets 8 degrees colder, by morning time, what's the temperature? -9, because now we've gone down another 8 and you're at -9. Mathematically, it looks like -1 -8 or -1 plus -8. I use negative and minus interchangeably. You'll hear me say both words all the time, and it just refers to the same thing. Minus if you want to talk about subtraction or negative numbers. It's a minus sign, but it's still a -8. It's a minus sign, that's, to me, that's a -1. If you put a plus sign in between there, it makes no difference. -1 plus -8 is still -9, and that's one of the first rules for integers. There's your horizontal number line. And then we have some inequality symbols, greater than, less than, in our equation. So here's some examples. And the thing that people get tripped up on sometimes is the order. Is the answer going to be negative or positive to this problem? Yeah, it's going to be negative because our first number is larger. It's going to be -5. And I could also write this 5 minus 10. It's the same problem. When you're in grade school, they don't teach you that because they don't teach you about negative numbers. They tell you you can only do this stuff one way. Not in algebra. Here's a problem, 8 plus -4. That plus sign doesn't do anything. You can ignore the plus sign in a problem like that because it's 8 minus 4. The only reason they did that was to make it look like addition. 8 minus 4 is still 4. So sometimes people will say, well, I'm combining a -4 with a +8. Okay, it's still, the answer is still 4. Even if you got to make it look like addition. Here's where we got two negative numbers being combined. Now, when I'm saying combined, it sounds like maybe that's addition. But I'm combining them based on their signs. They're both negative, so I'm going to get a bigger negative number. That's my temperature example there, starting at -1 and getting 8 degrees colder. Now I got -3 combining with -4, so I'm going to get -7. Classic addition here, 5 plus 2. Everybody should know what that is. That's 7. No mystery there. Now, here's where we get into the rules. There's 5 rules for integers. When we're adding with the same signs, we're going to add the numbers and keep the sign. So when both numbers are positive, you're going to get a larger positive. When both numbers are negative, you're going to get a larger negative number. We're just adding them as though they were just plain old numbers, and then we're going to keep the sign that they start with. So my example there, -1 and -8, I'm actually adding those two together. 1 and 8's 9. They both have a minus sign in front of them, so my answer is also going to have a minus sign in front of it. It's going to be negative. And these rules are on that Jamboard also. When we have different signs, we're going to subtract the smaller number from the larger number. And this is where people start to get confused because now it's different than what you might have learned in grade school. The signs are different. -3 plus 25. If I had that expression in -3 plus 25, I'm going to subtract the smaller number from the larger number. Okay, 25 minus 3 is 22. And the larger number is positive because that sign goes with it. So my answer is going to be positive 22. So for these blanks here, you're going to subtract the smaller number from the larger number and keep the sign of the larger number. If this was reversed or a different combination, -9 plus 17. Okay, 17 minus 9 is 8. 17 is the larger number, so my answer is going to be positive. If you notice, I could also rewrite these. I'm still going to have the same answer. 17 minus 9 is the same as -9 plus 17. But if I had 12 minus 17, this is where people get confused. My larger number is a negative number. I'm going to subtract 17 minus 12. It gives me 5. My larger number is negative. My answer is going to be -5. They don't teach you about numbers below 0 when you're younger. And so they would say you can't do that. Well, we know that's not true because Here's my check example. I had $12 in my checking account and I wrote a check for $17. I'm $5 in the hole, plus what else is the bank going to do? They're going to charge you a fee, right? $35 or something like that. And maybe whoever you wrote the check's going to hit you with a fee also. And now you've gone from -5, -35, now you're -40 in the hole, plus whatever the merchant wants to charge you. So don't do that. It happens to everybody. So those are the first two rules. Here's the same thing just filled in. Add the numbers and keep the sign of the numbers. That's the first rule. Same sign, add. That's how I usually break it down. Same sign, add. Different signs, we're going to subtract, keep the sign of the larger number. Okay, now we're going to look at subtraction. Some more rules. Rules. And these PowerPoints, these are all in your materials. So you guys have access to these, can look at them again if you want to. Here's a good example of a comparison of a couple of different problems that the only difference is a sign difference. Anybody see anything that jumps out at you about these two problems? Yeah, good. The first one on the left has one negative. The one on the right, they're both negative. So you're going to get a different answer. This first one on the left is that second rule. That's subtract, keep the sign of the larger number. So 40 minus 10 is 30. The one on the right, these are both negatives. So those are same sign. I'm going to add them. You're going to get negative 50. Where it really starts to get crazy, and I'm not going to go through all of those, is when you start seeing problems like this. It is -2 plus 8. Awesome. Jumping the gun. Help me with your name again there. Jaden. All right. Way to go, Jaden. This is what they call keep, change, change. That's the third rule, adding and subtracting. This is a double negative. If you think about the way we speak English, we will never get, well, you shouldn't hear anyone say, I'm not never going to do that. Right? We don't talk that way. Because what that means is, I'm not never going to do it. So does that mean you're going to do it sometimes? Or maybe you're going to do it all the time? It's the opposite. So that minus and that minus right together means we change the sign. This is keep, change, change. And I abbreviate this for KCC, just to remember. Keep the first sign, change the second sign, change the second sign, the third sign. So this becomes -2 plus 8. Now we're back into the other rules. So 8 minus 2 is 6. The only time you got to worry about that is when that minus is right together. The fact that the parentheses is here is only to separate this term from this. They're trying to make it look like it's regular subtraction. But keep, change, change. That's the third. This is where people really have the most trouble with all these adding and subtracting examples. Keep, change, change. Sometimes people will say keep, change, opposite.
I learned it. Keep, change, flip.
Keep, change, flip. That's another way people describe it. Good. See, here's it's still written as keep, change, opposite. And if you notice the way these 2 minus 8, okay, that's different signs. -5 minus 7, that's same sign. Now -4 minus a -8, that's keep, change, change. That's -4 plus 8. It's that double negative that turns into a positive. If we're speaking in English, if we have two negatives in the same sentence together, it turns into a positive. Math, this algebra works the same way as far as that goes. 2 minus -7. 2 take away -7. 2 plus 7 is 9. Another way to think about it is, let's say, in fact, accounting, they do this all the time. If they've mistakenly taken money out of your account, they have to undo, they have to subtract that, they have to undo that process to put the money back in. They're not going to add it back in because that would equal 0. They actually have to completely undo it. So that's the third rule. The last two rules are the easiest. Anybody ever seen this diagram before with the pluses and minuses? Oh, I know you have, Thelma. It looks like a tic-tac-toe grid. But for multiplying, and this is only for multiplying and dividing. The reason I say these are the easiest, because it's only 2 and they're short. For multiplying and dividing, if I have the same sign, I'm going to get positive. And so this little grid here, wherever you start, the next 2 in a row, the next one times the next one is going to give you the answer in the third box. So positive times a positive is a positive. Positive times a negative is a negative. Negative times a negative is a positive. Negative times a positive is a negative. So with multiplying and dividing, same sign is positive. -5 times -7 is 35. When the signs are different, you get a negative. Same sign positive, different sign negative. We're multiplying and dividing. So that's the 5 rules for integers. That's really the starting point for everything else that we end up doing in algebra. So I'm going to go back to that Jamboard real quick. And here's those same things that are kind of filled in. Subtracting integers, multiplying and dividing. That's on the wrong page. Somebody's moved it. Oh, somebody eliminated the problem, the page. Oh, here it is. It goes with this. Multiplying and dividing is just these two. Same sign positive, different sign negative. Adding and subtracting are these. Keep, change, change. Same sign, you add them and keep the sign. Different sign, you subtract and use the sign of the larger number. So questions, anybody? Okay, that's all the time we have for our Zoom session today. So my suggestion would be just dive into the materials. There should be, I want to say there's one assignment that's going to pop up. I think I have it scheduled for later today. Yeah, there's a practice assignment. And at 2 o'clock, actually, the first assignment for homework will pop in here. It's a Google Forms assignment. Not the stuff in Google Forms, because all you have to do is just type in your answer. Anything else, though, if you need to, if it'd be better for you to have it in paper, take a picture of it, send it to me. You don't have to give me the paper copy. Just get it to me some kind of way. Most of this stuff is just for practice anyhow. I don't have a zillion different assignments. What you're going to see here is we've got 3 unit tests. There's a test every 2 weeks. So there's hopefully enough practice and enough homework assignments during each 2 weeks to get you ready for those tests. And so those tests are going to be 80% of your grade. Homework's only 10%. Anything else you want me to look at that's not for a grade, I'll be happy to do that. And then the final is the last 10%. The final is only like 50 points. It's 10 problems, I think. So the 3 unit tests are going to be the bulk of your grade. And those are the ones you concentrate on. And if you do poorly, you can take it again. I got 2 versions of every unit test, so you can retake them. You can only do the final once, but the unit test you can do twice if you need to. And I'll give you the highest score that you get. So that's it for today, gang. Thanks for being here.
Thanks for being here. Awesome.
Thank you.
I'll try to figure out another way to show the stuff I'm doing on the board here also, since we're about equally split right now. So
I will see you Thursday.
all right, sounds good.
Bye.
Thanks, everybody.
Bye.